Pythagoras problems. Find A in the following diagram correct to three significant figures, and we can see the A just here. If I draw the outside triangle down here, this is 3 centimeters. We know this is a right angle. This is A, what we're trying to find. We don't know this length, but we can work it out using this triangle just here, because we know the hypotenuse is 4 and this side is 1. So let's call this one x for now. And we can say that x squared plus 1 squared, that's the two shorter sides squared and added, must be equal to 4 squared. So x squared is going to be 4 squared take away 1 squared. 4 squared is 16, so 16 take away 1, so it gives us x squared is 15. So x is going to be the square root of 15. I don't need to work it out at this stage. A is now the hypotenuse of this one. So a squared is going to be the square root of 15 squared plus 3 squared, and this is why I didn't need to work it out at that stage. The square root of 15 squared is just 15, and that's 9. So a squared is equal to 24. And therefore a is going to be the square root of 24. So I can calculate that, square root of 24. And I want 3 significant figures here, so that's going to be, well, this 9 actually needs to be rounded up. So that's going to be 4.90. So that's going to be 4.90 centimeters. Correct to 3 significant figures. Find A in the following diagram correct to 3 significant figures, and we can see A is just here. So how can I work that out? Well, I can work out this one using this triangle, and then work out the overall length using the big triangle around the outside, and then A would be y take away x. So x is a shorter side in this right angle triangle. X squared plus 8 squared is equal to 15 squared. So x squared is going to be 15 squared minus 8 squared. I've already done this on the calculator, you can see over here. So just go up here, 15 squared minus 8 squared is 161. And then x is the square root of that. I'm going to keep it to 5 significant figures because I want 3 significant figures for my final answer. So the square root of that is 12.689. If I keep in 5 significant figures. Okay. Now use the big triangle around the outside. Y squared is a shorter side in that, plus 8 squared, and that's going to be equal to 25 squared. So y squared is going to be 25 squared minus 8 squared. So y squared is 25 squared minus 8 squared is 561. And then y is going to be the square root of that, which is 23.685. If I keep 5 significant figures. And then we can say that A is equal to y minus x. So that is going to be 23.685 take away 12.689. And we want this to 3 significant figures. The 9 would round up, so it's actually going to be 11.0. And that would be in meters, correct to 3 significant figures. Find the distance between the points -3,5 and 7,0, correct to 2 decimal places. Sketch always helps with this type of thing. So negative 3, 5 is, say, here, and 7, 0 is, say, here. And what we're wanting is the distance between those. So D is this distance here, which is the hypotenuse of this right-angled triangle. Looking at the x-coordinates, negative 3 across to 7 means 10 across. Looking at the y-coordinates, 5 down to 0 is 5 down. So D is the hypotenuse, so that's going to be 10 squared plus 5 squared. It's 100 plus 25, which is 125. So D is going to be the square root of 125, which I think I've already calculated over here. And we wanted it to 2 decimal places, it's 11.18. We don't know the units. Find the area of the triangle below. We have the base, we don't have the height. But we do know the hypotenuse, so we can find h using Pythagoras' theorem. H squared plus 15 squared is equal to 17 squared, and therefore h squared is 17 squared minus 15 squared, and I've already done that on the calculator. We can see it's 64, which tells us that h is equal to 8. Then we can use area is a half times the base times the height, so that's a half times 15 times 8. So 4 times 15 is 60. So it's 60 square centimetres. Now this last one's quite a difficult problem, so go through it very carefully. A ladder is resting against a vertical wall, such that its foot is 1.5 metres away from the base of the wall. When OP steps on the ladder, it slips down the wall 0.25 metres, and its foot is now 2 metres away from the wall. Find the length of the ladder. So let's just get rid of that. Let's try to draw this situation. So here's the wall, here's the floor, and here's the initial position of the ladder. Clearly this is a right angle between the wall and the floor, and we know that this is 1.5 metres. So he steps on it and slides down a bit, so we get something like that. We know that this distance is now 2 metres, and this small distance up here was 0.25 metres. Let's draw each triangle separately. So there's the initial position, and this one is after the slippage. We're trying to find the length of the ladder, which is the same obviously in both triangles. This was 2 metres. Let's call this one x. When this is 1.5 metres, because it slid down by 0.25, this would be x plus 0.25. So applying Pythagoras in this one gives me that L squared is 1.5 squared plus x plus 0.25 squared. So 1.5 squared is 2.25. And then if we expand this, remember what we're doing here is expanding x plus 0.25, x plus 0.25. So we've got to expand that out. So that would give me x squared plus 0.5x plus 0.25 times 0.25. I'm just going to bring the calculator in for that. So 0.25 times itself just means squaring it. So that's 0.0625. Let's just get rid of this because that was there for explanation. We might need that space in a moment. So L squared, not T squared, L squared is going to be x squared plus 0.5x plus 2.25 plus 0.0625 gives me 2.3125. Okay, so let's leave that one there and then go to this triangle. So that L squared is just going to be x squared plus 4. So both of these are L squared, so what I could do is write x squared plus 4 is x squared plus 0.5x plus 2.3125. Subtract x squared from both sides, and then 0.5x can be equal to 4 take away 2.3125. So let's just work that out on the calculator. So we've got 4 take away my last answer. So that's 1.6875. And then x is going to be that divided by 0.5. Last answer divided by 0.5 is 3.375. So let's come back with that information to this equation. So L squared is going to be 3.375 squared, replacing x with 3.375, add 4. So bring the calculator back in. Try and find somewhere we can see it well enough. And we've got 3.375. And we want to square that and add 4. So that gives me 15.39 and so on. So 15.39 and so on. And so L is going to be the square root of that. So square root of my last answer gives me, I'll give it as 3.92. So 3.92 meters to 2 decimal places.